Hey guys, welcome to video 2 for today, the moles to particles conversion. So the weird word in that sentence was the word moles, which is what this unit is all about. It's all about moles and using them to make some calculations. So we definitely got to know what a mole is. Now, a mole is representative of a number of particles. So that in that sentence probably makes no sense to you. So we're going to think about it like a dozen, okay? When you hear the word dozen, you instantly think of a number. You think of the number 12 because 1 dozen equals 12 things, 12 of whatever it is you're looking at. You could have a dozen eggs. You could have a dozen donuts. You could have a dozen people. Whatever it is, 1 dozen means 12. Mole is the same way. 1 mole of anything is a specific number of that thing. It's just that now the number isn't 12. It's a crazy big number. It's this number over here. 6.02 times 10 to the 23rd. So that's 6.02, but you add 23 more zeros or move the decimal 23 times, which is a crazy big number. It's called Avogadro's number. Yes, Avogadro, not avocado. Named after a man, Avogadro. And 1 mole is Avogadro's number, 6.02 times 10 to the 23rd things. Okay? And we're pretty much always going to use them for particles. We'll talk about what particles are in a second. So what we're going to be using is this idea of a mole as a conversion factor. So in our previous video, we were looking at plugging these conversion factors in to make conversions where you said one thing is equal to another thing. And our conversion factor with moles is that 1 mole equals 6.02 times 10 to the 23rd particles. Now, particles can be several different things. If you've got an element, its particles are atoms. If you've got a compound, its particles are molecules. So like atoms would be hydrogen, or molecules would be H2Os. And then if you're in pre-AP, you may also need to go to ions. So that would be like calcium in the compound CaCl2. You'd say how many calcium ions are in so many moles of CaCl2. So particles can be any of these things depending on what you're starting with. Let's look at number 1 here. How many atoms are in 0.50 moles of aluminum? So you're starting with 0.50 moles, and that is of aluminum. And we're trying to get to atoms. So we're going to use this information to make up a conversion chart here. Starting with our given information. The given information is 0.5 moles. And what you're going to need to start doing when you draw these tables is putting the substance with it, because eventually we're going to be switching back and forth between substances. So it's a good habit to be in. We've got 0.5 moles of aluminum. And we're going to go to atoms of aluminum. So we need a conversion factor that switches from moles to atoms. Luckily, we just learned one. It says that 1 mole, and MOL is the abbreviation for moles, 1 mole is 6.02 times 10 to the 23rd particles. And since this is just an element, aluminum is simply an element, that is a number of atoms. So we'll say 1 mole, which goes on the bottom to cancel out moles on the top, 1 mole of aluminum is equal to 6.02 times 10 to the 23rd atoms of aluminum. So moles and moles cancel, and we're left with just atoms of aluminum. So you do 0.5 times 6.02 times 10 to the 23rd, multiply those two, divide by 1 is going to give you 3.01 times 10 to the 23rd atoms of aluminum. And that's your answer. There's that many atoms of aluminum in 0.5 moles of aluminum. All right, let's try number 2 down here. we got how many moles of sulfur are in 1.8 times 10 to the 24th atoms of sulfur. So we find our given information right here, 1.8 times 10 to the 24th atoms of sulfur. Slap that sucker right here in the upper left-hand corner, 1.8 times 10 to the 24th atoms of sulfur. And we got to convert that to moles. So what you do is you use your conversion factor. 1 mole equals 6.02 times 10 to the 23rd atoms, according to Avogadro's number. Now we're going to take that and plug it into the chart. You've got atoms of sulfur on top here, so you're going to need atoms on the bottom. The number that goes with atoms is 6.02 times 10 to the 23rd atoms, and we're still in sulfur. So we put what that is equal to on top. That's equal to 1 mole of sulfur. And now we have canceled atoms and atoms. We're left in moles, which we're looking for. And you multiply the two things on top, divide by the thing on the bottom. Now this one's a wee bit tricky when you type it into the calculator. You either need to type it in fraction form, where you've got 1.8 times 10 to the 24th on top of the fraction, and 6.02 times 10 to the 23rd on the bottom of the fraction, or you need to type it in using parentheses, where you do 1.8 times 10 to the 24th divided by parentheses 6.02 times 10 to the 23rd. Otherwise, it'll divide by the 6.02 and then multiply by the times 10 to the 23rd, which will not get you the correct result. And I'm not going to go whip out my calculator here, but it should be something along the lines of 3 times 10. No, just 3. 3 moles, somewhere around 3 moles of sulfur. Maybe like 2.99 or something, but somewhere close to that. All right, now if you're in pre-AP, we're going to do the next question. If you're in regular, you don't have to do ions, so you can just go work on your practice. You're good to go for that. But pre-AP, stick around. We're going to do this one together, and it is a little bit more complex than the previous examples. So in this one, we're going to look for how many chlorine ions are in 1.25 moles of calcium chloride, which is CaCl2. So we're going to take that given information, 1.25 moles of calcium chloride, and we're going to slap it in that top left-hand box. Now, it is important here that you include your substance, your CaCl2, because we're going to go from calcium chloride to just chlorine ions. So it's important that you write the substance. Now we're going to need 2 conversion factors here. The first one is the normal one that we've been using with Avogadro's number. The 1 mole is 6.02 times 10 to the 23rd molecules. But we're also going to need to go from molecules of CaCl2 to chlorine ions specifically. So we're going to look at just 1 molecule of CaCl2. And what one? Oh wow, I messed this sheet up. This should be ions of chlorine. So I'll mark that out. Put just ions of chlorine. Now 1 molecule of CaCl2 looks like this. CaCl2. No, this is not a correct Lewis structure. Also, it wouldn't have a Lewis structure because it's an ionic compound. But you'd have calcium bonded to 2 chlorines. So for every molecule of CaCl2, you've got 2 chlorine ions. So we're going to use these conversion factors to go from 1.25 moles of calcium chloride to ions of calcium chloride. First, starting with the thing that has moles of CaCl2 in it, which is this top conversion factor. We say 1 mole of CaCl2 has 6.02 times 10 to the 23rd molecules of CaCl2, because that is a compound. Compounds have molecules. So moles and moles will cancel. We're in molecules. We also know that 1 molecule of CaCl2, molecules and molecules, has 2 chlorine ions in it. 2 ions of chlorine, which is negative. So molecules and molecules will cancel, and we'll just be in ions of chlorine. You'll multiply across the top, divide by the bottom ones. So you 1.25 times 6.02 times 10 to the 23rd times 2, which is going to get you some number. It's late. I don't have a calculator sitting here next to me, so I'm not going to do that out. But it should not be super duper difficult. Actually, I just kind of did it in my head. It should be somewhere around 15 times 10 to the 23rd ions Cl. So that is how you extend it to ions. You might have to go backwards from that, but hopefully you can figure it out. Go work on your practice. That should be in Google Classroom. If you need any help, as always, email me or whoever your teacher is, or come to office hours and get some help.